circumcenters are created by perpendicular bisectors. Incenters are created by angle bisectors. So centroids are technically created by medians. A median is technically a midpoint. It's a line that connects a midpoint to its opposite vertice or its opposite vertex. So right here would be like your vertex. So it connects a vertex to its opposite midpoint. So if you take one of your colored pencils, a median technically is the line that's created whenever you connect the vertex to the midpoint. A midpoint's made by just cutting a side of a triangle in half or a line segment in half. So a segment joining a vertex to the midpoint of the opposite side. So I want you to take a different color and we're going to eyeball this. Obviously, you're not a computer. It's not going to be perfect, but it's okay. So take a different color. We're going to try to find the midpoint of this side. So the midpoint is in the middle. So it looks like it's kind of be like, I don't know, right there. Okay. So we're going to take this midpoint that we just made and we're going to connect it across to the opposite vertice. So okay. And then we can do that again to the third side. And once again, it's not going to be perfect, but it's okay. The third side of the triangle, I'm going to do the same thing. I'm going to eyeball where the middle is going to be between the two ends. So the midpoint looks like it's kind of like right here-ish. And then we're going to connect that midpoint opposite vertice. So opposite vertex is going to be over here. Now, technically, where all these three medians connect is forming the centroid right in the center. So we could actually construct this using like the compasses. We could find the midpoint and then go across. But this is just like an eyeball of it. So your centroid is whenever the three medians of the triangle actually intersect. It's called the centroid whenever they cross. We're going to look at picture first. Now, if you look, they have these pieces tick marked. The reason why is because you have to remember that D is technically the midpoint of AB. So that would make sense for these pieces to be the same amount. F is the midpoint for AC. So these are congruent. E is the midpoint for BC. So if I knew this side was 10, that would automatically be 10 as well. So the sides are breaking up into pieces. So we're going to list all the medians. So we're looking inside the triangle. If I say one of the medians is B to F, right through there, what is another median? D to C, and then E to A. Those are my three medians. Where they intercross, where the medians intercross, is at what point? P, which is called the centroid. And this is where it gets a little funky. This is where it gets a little weird. It will make sense whenever we start involving numbers. So keep this like as an open mind. So technically there's special properties that exist for each of the medians. So they're kind of like little equations that you can use. What I want you to think about is each line. So pick one color. We're only going to use one color for this picture. I'm going to use A to E. A to E is actually being split into thirds. Okay, so we have one line. P to E technically represents 1/3 of the line. A to P would have to represent how much of it? 2/3. So we're actually going to put a little dot on here and we're going to break it into literal 3 segments. So I have one piece here, one piece here, one piece here. There's 3 total pieces. A to P would represent 2 of those 3 pieces. P to E would represent 1 of those 3 pieces. Okay, there's 3 total pieces. So we're going to kind of break this up into a bunch of little formulas that you could technically use to solve this. So if I say AP is equal to some amount of AE, AE's being the whole thing, technically what's my fraction to represent AP out of AE? 2/3, because there's 2 pieces here. So we're going to say 2/3 times AE. So if I knew the whole length of AE, I could multiply by 2/3 to represent AP. If I wanted to know AP compared to PE, which is like the little tiny piece, not 1/3, not 2/3. Oh, 2/3. Okay, yeah, 2. Sorry, my bad. So you would have to multiply PE by 2 to represent AP because this is my little piece. So if I double this, that's going to represent this amount. Now we're going to kind of work backwards. We're going to look at our little piece. So if I wanted to know how much PE is compared to AP, what would I have to multiply AP by to make PE? Not 1, not 1/3, because AP is this amount. So how much would I have to multiply? Okay, hold on. How much would I have to multiply this by to get this? Not 2, because am I getting bigger or am I getting smaller? 1/2, because I'm getting smaller. So if I cut AP in half, that would make PE. And then the last one we're going to compare it to is, let's do PE compared to the whole distance of the line, which is AE. How much would I have to multiply AE by to represent PE? Not 1, 1/3, because it represents 1 out of the 3 pieces. Yep, but it's going to be a lot easier. Because right now it's like working with like letters and formulas and it's like weird to some people. When you see the numbers, it's going to be a lot easier. Everybody liked this way better all day than using the Pythagorean theorem and doing all that craziness last week, okay? Let's go to number 2. So numero dos, we're going to start by putting our numbers in our picture. It says if Z is the centroid of triangle TUV, TZ is 60. So I'm going to highlight TZ. TZ is 60. Now, technically, that's the big portion. So how many pieces are actually in that line? 2. There's 2 pieces right here out of 3. So instead of writing 60 here, I'm going to split it to represent how much is each little piece. The whole thing 60. How much is each of those pieces? 30. So I'm going to put a 30 here. I'm going to put a 30 here. Where else could I put a 30? ZY, because technically that's the third piece of the line. So actually each piece is 30, 30, and 30. The next one says XZ is 28. That's this little tiny piece. Should I cut that in half? Or is that like the number, like does that represent 1/3 or does that represent 2/3 of the line? Represents 1/3. So this is 28 exactly. I'm not splitting it at all. If that's 28, how many 28s are on the other side of the line? 2. So I'm going to put a little point and I'm put 2/3 or 28, sorry, 28, because there's 2 28s over there. And then we have WZ, which is 25. That's nice because it's my little piece. Do I have to cut that in half at all? Nope. So that's going to stay as 25. And then how many 25s are going to be on the other side? 2. Okay. So it kind of looks like a lot, but it's all right. How much would Z to V be? 56, because it's 28 plus 28, because there's 3 28s to make up the whole line, and I only want 2/3 of it, which is 56. What about Z to Y? 30. Z to U? 50. T to Y? 90, because that's 3 out of 3. So I have 30 plus 30 plus 30. So 90. And then X to V. Yeah, it makes a lot more sense with numbers. 84, because you have 28, 28, 28. So you're thinking each line is splitting into a third. You just have to look. Are you given the little side or are you given the big side? If you're given the big side, you're cutting it in half to make each little piece. If you're given the little side, it's just that same number that goes across. Okay, so let's go to number 3 and do it again. Take a second. Try to put number 3's numbers in your picture. Okay, why do you think I put this 8 off to the side a little bit? Because the whole thing is 8, and that's technically the long piece. This is the short piece, right? So this is the long piece. So technically there's 2 portions here. So how much is each one of those little segments? 4. So we have 4 and 4 because the whole distance is 8, and that's 2/3 of the line. So technically I'm going to cut 8 in half to represent 4 and 4. So then how much is this little piece right here? 4, because they would all be 4. If this, the next one that they gave you was 7. 7, if you look at your picture, that's the short piece compared to this piece. So this represents 2/3. That represents 1/3. So how many 7s are above it? 2. So we have 7 and we have 7. Same thing over here. Do I have to split 5 in half? Nope. 5 is a small piece. So how much is technically over here? 2 5s. So 5 and 5. And as you get to like doing them, you'll realize instead of putting 5 twice, if you want, you could just put 10 there. Instead of putting 7 twice up there, if you just want to put 14, that's totally fine. A lot of people will still just split it into thirds because it's like less to think about. So G to D is how much? 4. A to D is 12 because it's the whole thing. So if I have 3 pieces of 4, 3 times 4 is 12. What about C to G? 14 because the little piece was 7. So I double 7, that makes 14. And then G, 10. And then B to E, the whole thing, 15. Easy peasy. Okay, try number 4. This is a lot better than last week. There's no Pythagorean theorem, which is nice. You like the Pythagorean theorem? People are like really struggling. Okay, so if TU is 27 and it's the whole thing, what are you actually dividing by? Dividing by 3 because it represents the whole thing. So if you divide by 3, how much is each little piece? 9. So this is 9, this is 9, and this is 9. If SW is 18 and that represents the whole thing, how much is each little piece? 6, because you're dividing by 3 again. And then same thing with the last one. The last one's 21. So each piece is how much? 7. So you got 7, 7, and 7. So how much is TX actually going to be? What'd you say? 18. What about X to U? 9. What about S to X? 12. And then X to W? And then RX? 14. Nice. Okay, we got one more we're doing together, which is number 1. So try number 1. Easy peasy lemon squeezy. This is not bad. Yeah, we should have started with this. Thought people were going to struggle with this. And then first period was like, How do we do? Easy peasy? Maybe. If this whole thing is 22, then how much is KM? 11, because it cuts it in half, because it's technically a midpoint, so it cuts it in half. N to L, 13, because if that side's 13, then this side is 13, because midpoint cuts things in half. How much would KL be? 26, because the whole thing, 13 plus 13 is 26. JO, 18. And then JL, the whole thing, 36. How do we feel? It's not terrible. Okay, you got all the questions on the back. We're not skipping any. If you want me to check it when you're done, you can bring it over here. And I can just mark you off today. If not, I'll check it tomorrow.